Circular motion assignment question 2, 2A. You can see the answer from here, from your computer. You can pause and just take a look, right? Let's go to 2B. Now, in 2B, you can see there's a boy sitting on a sphere, right? And they ask you to draw the free body diagram. The free body diagram should look like this. It should have the normal reaction force. This is the force acted by the sphere on the boy. There is a weight, mg, acting perpendicularly downwards, right? Vertically downwards, right? You might just want to label it, right? Normal force by sphere on boy, right? And this is mg, weight of boy. Okay, so this is your free body diagram. And the second part of the question, so this is part 1, 2B part 1, right? It's 2B. And this is part 2. Okay, now it says, would this be a uniform circular motion? The answer is no. Simple reason. Now when the boy slides down, he loses gravitational potential energy, and the GPE lost, right, is converted to KE, kinetic energy, right, and thus V will increase, and circular motion will not be uniform. Okay, so that's part 2. Let's go to part 3. Okay, in part 3, it asks you at what speed, right? At what height, sorry. At what height would the boy loses contact? Now if you look at my diagram again, I draw this diagram over here. I just draw the outline of the sphere, okay? The boy has the weight. Now, we assume at this height, this is the height, right? This is the highest height. This h, small h, right, is the height whereby it falls. Vertical height fall, right, from the top. Now, this is r minus h, right, where r is the radius of the sphere. Okay, look at the angle, theta. This is theta as well. Okay, mg is here. Okay. Now, we found two equations. We say mgh, which is the change in gravitational potential energy, is equal to half mv squared, the gain in ke. Okay. Initially, we assume the boy has no speed, right? Has no velocity. And we also write this mg, okay, cosine theta, right? We'll equate that to mv squared over r. That's the centripetal force, right? Now, if I take, let's see. Okay, let's do this, right? If I take 1 and 2, right? If I take 1 divided by 2, what will happen? 1 divided by 2, okay? That will give me h over cosine theta is equal to r over 2, right? Yeah, I think so. Now that will mean 2h is equal to r cosine theta. Okay, now interestingly, if you look at this, right, cosine theta, since this is also theta, right, cosine theta would be r minus h over r, right? R minus h over r is cosine theta. Okay, r minus h over r, 2h. Okay, so 2h is equal to cancel r minus h, right? So 3h will be equal to r. H is equal to r over 3, right? Okay, so now r is the drop of the boy from the top. Okay, that means the height of the boy when he loses contact. When there's no more n, just left mg, right? Now, this height is actually r minus h. Okay, I'll say therefore the height, right, is r minus h is equal to r minus r over 3 equal to 2 over 3 r right? Ignore this. This is a diagram that I drew earlier. Okay, it should be 2 over 3 multiplied by 5 meter. That's 3.33 meter. That's the answer. Okay, there we go. Now the last part. If friction is not neglected, would the height be the same, right? Okay, let's do over here. This is part 4, right? The height will be lower. Height will be lower. Why? Because GPE is lost to friction. Okay, lost to frictional forces. Okay, it's lost to frictional forces, and less of it is converted to KE, right? Thus, you need to cover, the boy needs to cover a longer distance, right? To gain enough velocity to break contact with sphere. Okay, so that's your reason. So the height will be lower, right?